Welcome to our first online lesson. This lesson is going to cover part of 6.6. As we talk about 6.6, it's going to be very similar to what you guys did in the graphic organizer that was sent to you online or that you did in class last Wednesday. We're going to talk about basic right triangle trig, how to find an angle, Pythagorean theorem, angle of elevation, and angle of depression. The next few days we're going to be working on assignment 13, 14, and 15, all out of the textbook. This will follow a WAMAP assignment. Please remember that your calculator should be in degree mode for all of these questions, and then you want to round to about 3 decimal places. If you notice that the triangle is a 45, 45, 90 triangle or a 30, 60, 90 triangle, then your exact answers should be provided and there will be no need for decimals. As we look back to our right triangle trig that we worked on in Algebra 2, let's start by remembering that all lowercase letters represent sides and capital letters are always used for angles. Depending on what angle you're standing at will tell you what ratio you're going to use. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Some of us will remember SOHCAHTOA. As the acronym to help us remember what those ratios are. It's all based on perspective in terms of what you know or what you're looking for in terms of which ratio you're going to use. The nice thing about right triangle trig is that it's going to be set up with equal proportions, and there is only going to be 3 actual positions where you can put a variable, which limits the possibilities there. Either your variable is going to be in the numerator, in the denominator, or you're solving for an angle. If your variable's in the numerator, your first step is always going to be to cross multiply. From there, you could pick up your calculator, type that in exactly how you see it into the calculator, and then round appropriately. For the second one, as your variable is in the denominator, you need to first start by cross multiplying, just like you did on the first step. But now to get 18 by x by itself, you're going to divide both sides by cosine of 56. Then you can pick up your calculator, type that in exactly how you see it in the calculator, and get an answer out. For the third example, when you're solving for the angle, that's when you're going to use inverse tangent. So that's the second tangent, has a little -1 in the power, and you take inverse tangent of your ratio. And then round appropriately. If your variable is in the numerator or the denominator, this is when you are solving for a missing side. If your variable is next to the word tangent, that's when you're solving for an angle. The question I get most frequently is, how do I know if I'm solving for a side or solving for an angle? And that's going to be based on the information you know or you're looking for. So let's go through a couple examples together. Helpful hint. I always look at what information do I know, and I draw a little stick figure in the angle that I'm either looking for or that I know. And I say, how do the sides relate to me in that angle? This side is across from me, so that's my opposite. This side is my longest side, which is my hypotenuse, which tells me I'm going to use sine. So I set that up. Sine of 27 is 2x over 312. And just like before, because our variable is in the numerator, we're going to multiply both sides by that denominator. Type that in our calculator. get our answer. For the second example, again, I'm going to put myself in the angle I know. Say, how does this information relate to me? This is across from me, so that's my opposite. This touches me, so that's my adjacent, which then tells me I'm going to use the tangent ratio. So tangent of 39 equals 23 over x. For this particular example, again, my variable's in the denominator, so I cross multiply and then divide by tangent of 39. To get an answer of approximately 28.403. Again, you want to make sure your calculator stays in degree mode for all of this. Anytime you reset the memory, it's going to go back to radians. The vocab that we want to focus on when we're solving for an angle is using that word inverse tangent. Again, it all depends on perspective. If I was to solve for angle A, we're going to use a capital A here to represent the situation, which means it's going to be across from side A. The sine ratio then would be opposite over hypotenuse, so that would be A over C. The second one is cosine. Again, if I stay at angle A, that's going to be adjacent over hypotenuse. And then tangent inverse is opposite over adjacent. So we want to remember that if we take the inverse of something, we are finding an angle. When we're using regular sine, cosine, or tangent, we're finding a side. Again, it's all based on perspective from what angle you are solving for or what angle you have known. So here, let's just pick the angle that we know. Again, I like to draw myself as a little stick figure. For this one, I know all three sides, so I technically could use any of the ratios. So let's just pick one of them. Let's pick cosine. And your ratio for cosine is adjacent over hypotenuse. So x is going to equal inverse cosine of that ratio. Then we pick up our calculator and we round appropriately. This time we're solving for an angle, so we want to make sure we label that with a degree symbol. Let's choose a different ratio for the second one. I used cosine before, so let's use tangent this time. Tangent, your ratio is opposite over adjacent. Again, for this particular example, all three sides were known, so you could use any of your ratios that you choose. We'll get the same value out for that angle. I'm solving for x. I'm going to take inverse tangent of that ratio. Again, only then will I pick up my calculator and type that in the calculator and get 16.26 degrees. Again, make sure you use your degree symbol to denote that we're finding an angle. The next thing I want to talk about is the story problems. We'll have lots of story problems in this section. For this one, we're planting a tree with a guide wire that helps support the tree. That's what you guys will see in your neighborhoods as new trees are planted, to kind of the wires that hold your tree up in case it gets windy. So let's start by drawing a picture. I'm going to draw a little tree here. It doesn't have to be the best drawing, but it is helpful to have a picture of a tree. It says that an 8-foot guide wire is stuck to a stake in the ground, so we know that that wire is 8 feet long. Once we kind of see where that wire goes and what our known information is, then we would want to draw in our right triangle, and we can see that that's going to attach to the stake in the ground, create a right triangle. It tells us that that is 42 degrees, so we label that interior angle as 42 degrees, and it wants us to find the height to the connection point on the tree, so that's where we're going to put our variable. So we're looking for that vertical distance. So from our known information, we know that we are looking for the opposite side, and we have the hypotenuse, so that tells us we're going to use sine. So we're going to have sine of 42 equals x over 8. Again, the variable I'm looking for is in the numerator, so I'm going to cross multiply by that denominator. Once I have that ratio completely written out, then I pick up my calculator, type that in my calculator, and I get 5.353. Let's go back to the problem. It says to the nearest tenth of a foot for this question, so we're going to round that down a little bit more to get 5.4, and we are talking about a foot, so we want to add in our label there to denote that we have finished the question. Our last problem that we're going to deal with today is dealing with the angle of depression. This one I think gets missed most often by students. It says when flying home from Disneyland, you look at the airport. So let's draw a very rough sketch of an airplane. Remember, if you look forward on the airplane, that is what you will see. That is your line of sight. That's your guide. Anywhere you look to deviate from that line is your angle of depression. So if I look down to the airport, that is the angle, that is 28 degrees. It says that the pilot says that we were at a height of 1,100 feet, and we are looking for the horizontal distance. Again, this one is going to be most crucial to get your picture drawn correctly before you do any of your calculations, so you pick your right ratio. From here, I know the opposite side and looking for the adjacent side, so that's my tangent ratio. I'm going to cross multiply, divide by tangent of 28. And that's the value I would type in my graphing calculator to get 2,068 feet, and then it's 0.799. This one didn't tell us what to round to, but just to round to the nearest tenth like we did on our last question. This would be 2,068.8 feet. That's the end of what you guys will need for the assignment today. After you copy this down, you'll join me in the chat room, and at that point we will go over questions, clarify anything, and you will get your exit test.